Hello, everyone. Good morning, good evening to everybody based on the time zone you are listening to this uh, the video recording. This is Saminathan Raju, and this is my video presentation for the stress assignment number 4, Java crash course. Right, and let's go to the first question there. Show a full program and then reverse engineer it. Show how it works and why. And in order for me to answer this question, let me club the first and third together. That's what does public static void main string args mean, right? So let me quickly jump onto those so that I can explain those together. Okay, let's say this is a complete Java program. It's like a very small program, but it's still a complete one, right? Public class hello world, public static void main string args, and then you are printing an hello world text, right? So let me take this and then explain. So the public class hello world. So what does that mean, right? So in order for me to explain that, all you got to do is that to understand the visibility modifiers of Java. So we have like by default default is first category, but it is still there, right? But the default, if you don't specify, then that is default, right? And outside of that, we have like 3: private, public, and protected, right? So the default is something that when no access modifier is specified for a class or a method or a data member, then it is said to be having the default access modifier. The data member, class, or methods that are not declared using any access modifiers that are default, but if they are only within the same package, right? And then the next comes is the public. The next comes is the private visibility modifier. The private visibility modifier is with the keyword private. The method or data member declared as private or accessible only within the class in which they are declared. So any other class of the same package will not be able to access these members. Top level classes or interface cannot be declared as private because private means only visible to the enclosing classes. Protected means only visible to the enclosing classes and any subclasses. So these modifiers in terms of applications to classes, they only apply to nested classes and not to top level classes. Then what comes is the protected. What we see here, the next is protected. So the protected access modifier is specific to using a keyword protected. So these methods or data members declared as protected are accessible within the same package or subclasses in different packages. Then the last one is public. Public access modifier is specified with the keyword public. So the public access modifiers has the widest scope among all data access, all other access modifiers, excuse me. Classes, methods, or data members that are declared as public are accessible from everywhere in the program. So there is no restriction on the scope of a public data member. If you take this an example, we have public class hello world. So the public. So we have already discussed what public is. So let me quickly jump to a class keyword. That is the next keyword. What does class is, right? So the class is actually in the context of Java. So they are the templates that are used to create objects, and they are there to define object data type and methods. And so that is basically what the class keyword says. And the next is hello world. That's the third word of the first line, hello world. So hello world is nothing but the name for the class that you provide. And it is user selection, whatever the user wishes to name, they can name it that way, but without excluding any Java keywords. Java keywords are case sensitive in nature, but it is excluding a Java keyword. For that instance, you cannot create a class by the name of class, right? That's what actually I had said. So it is case sensitive and excluding all those keywords, anything that would be eligible for a class name, right? And we are specifying the class to be of a public scope, so it is open to all. So as we already seen. So let me quickly jump to the second part of the question: public static void main string arg. So what does that mean here? Right? So public. The public is, as we know already, it is the access modifier of the main method. So it has to be public so that the Java runtime can execute this, right? Remember that if you make any method non-public, then it is not allowed to be executed by any program, right? So there are some access restrictions applied on top of that. So it means that main method has to be public, right? What happens when main method is not public, right? So you would get an error message like, say, main method's not found in the class, right? So for this instance, say the class is test, it's going to say that main method is not there in the class. But again, this error method is subjective based on what IDE you want to use. I'm using IntelliJ IDEA here. Let's say, for instance, I'm not having a keyword public. And then if I try to run, I'm going to get a message saying, nope, no such method exception main. So again, it's like, it's going to be different. For example, Eclipse can give you one error, IntelliJ IDEA can give you, the same error, maybe in a different encapsulated form of it. Okay, and if I use public, then it's going to give me this text, hello world. Then static. So what does static mean? So when a Java program starts its execution and there is no object of any classes actually present, that is exactly why the main method will need to be static, so that the Java virtual machine can load the class onto the memory and then call the main method. So if the main method is not static, then JVM wouldn't be able to call it because there is no instantiation for any class that can happen. So let's see what happens if we remove the word static here. We get a message saying that the main method should be static. So it's very clear that it needs to be static, right? So let me put it back in. Then the next comes is void. Void means it returns nothing. So in other words, it returns 0, right? Void returns nothing. Excuse me, let me correct it. So void means it returns nothing. When you return 0, you are still returning an integer. So I'm sorry, I'll take it back. So void is we're returning nothing. It doesn't return any. So Java main method doesn't have to return anything. That's exactly why the type is actually void here, right? This has been done to keep things simple, because once the main method is finished executing, Java program terminates. So there is no point in returning anything. So there is nothing that can be done for the returned object by Java virtual machine. If we try to return something from the main method, it could give us a compilation error for unexpected return value. So let's see, what if we don't have a void? I'm removing it. And let me try running. Okay, it says invalid method declaration, return value type required. So that is if I remove void. And let's say, and remember, there's a compilation error. So if I say void, and instead of this, let's say I return 0. Right? It says unexpected return value. So you cannot, return anything from a void, and you cannot remove void either. So it needs to be void, and it cannot return anything. Okay. Let's get back. Then the next is the main method, right? So this is the name of the first Java entry point, right? It is fixed. So when we start a Java program, it first looks for the main method because it is actually an entry point. So if we have a class below, and then if you change main to say my main or something of that kind, then it's going to tell you saying that, oops, I don't understand what you're trying to say. Right. Okay. So you get an error right there. It doesn't understand it. So main method is important for a Java program. Yeah, to work. Okay, so that is the main. Then the next comes is the string arguments, right? So Java main method accepts a single argument of string array type, right? This is also called as command line argument. It is there in any high-level language for that matter. So let's have a look at an example of this. You have a Java command line argument, string args, and then you're trying to print a string here. And if your input is this, then you're going to have 1, 2, 3. If the test 1, 2, 3, then the 1, 2, 3 will be printed because it rejects exactly what is passed as a command line argument when the program is compiled. And if you pass a string in enclosed double quotes, then you're going to get that string printed underneath for you. Then it would return to the cursor. So that is pretty much what the answer for those two questions are. Let me just quickly sum it up. Public static void main string args. Every single word has a meaning to it. Public, the scope has to be public, because it's a very first of the program, and you cannot restrict it, because any private or protected member would need another class for object instantiation and consumption. So this method has to be public because it's the very first entry point. Static, you don't really have any object instantiation to occur, so it needs to be identified by itself, right? So that's the reason why you have a static there, right? And void, of course, there is no point. Once the main method finishes execution, it cannot return anything. There is no point for it to return anything. That's why it's void. And main, it needs to be a main method. It is the first point, and it is a keyword. It's a main entry point of the program. The method name needs to be main. And the string argument, it's an array. When with an open close square brackets, you're specifying it as string array. So that is command line argument. You pass it alongside the command line when the program begins the execution. Okay, so that is the answer for those two. Then let me see what the next question is. Okay, what is Java used for? I'm going to the second question there. That's probably the answer. What's Java used for? So Java is a programming language. It's a computer programming language. It enables programmer to write computer instruction using English-based commands, right? So it's very easy to get accustomed to it, and there is no jazzy or fancy, jargons used. It looks like a plain simple English. Of course, there are some syntax, and the syntax are kept so close to English language as possible, right? So yeah, it enables programmer to write computer instructions using English-based commands instead of having to write in numeric codes. Remember traditional assembly language programming, you got to probably memorize certain numeric codes, and then you key in those numeric codes, and it is not the case anymore here with Java. It's known as high-level language because it can be read and written easily by humans. Like English, Java has a set of rules that determine how the instructions are returned. So these rules are called syntax, right? Once a program has been written, the high-level instructions are translated into numeric code by the machine itself, right? That computer can understand and execute. So there are like two stages of processing. So first to binary code or assembly code, and then to native code. There are lots of application and website that wouldn't work unless you have a Java installed, right? So it's like more and more created every day. So Java is fast, secure, reliable. Right from the laptop to data entry machines to game consoles to scientific supercomputers to cell phones and to internet, Java is almost everywhere, right? And there are like multiple types of Java applications, that can be returned. So one would be like, say, standalone applications. So the standalone application is a program that runs on any machine independently. It's more or less like a C or C++ program, right? And the second type would be, say, applets, right? The applets is an application designed to travel over the internet and to be executed on a client machine by a Java-compatible browsers like Netscape or Internet Explorer. Modern days, you can probably say Chrome, Firefox, and all that stuff. And by far, the browsers are getting equipped themselves to understand more and more of inbuilt Java applets or Java codes by itself, so that it can, excuse some natural typos and all that while the applet or any particular bits are shipped in. So they have an autocorrect mechanism. Most modern browsers nowadays do come with some autocorrect mechanism. Like, say, for example, in a JavaScript applet, if you're trying to render, and one thing, applet cannot be rendered by itself. Applet need to be embodied onto some, say, HTML or so, right? And yeah, so applets are also Java programs, but they reside on servers, basically. That's why it needs to be shipped over the wire to the client machine. An applet cannot be executed like a standalone application or what we discussed at the very beginning, right? But it can only be embodied onto an HTML page, like an image or a sound file, whatever. And the third part is actually the web application, right? If you access something on the web server, then you're opening up a web application by some form. And they're accessed through web clients via the web browsers like Chrome or IE or so. So whenever you access some website by specifying the URL, you are accessing a web application. So main component of a web application is returned in a high-level programming language like Java. So there are many things that can be returned using Java, like say servlets that can be returned, Java server pages that can be returned, HTMLs. Java servlets are also Java programs, right? So which is embodied onto HTML. And you can access web application by specifying a URL. A URL corresponds, if a URL corresponds to HTML page, then the web server simply returns a HTML page to the client where the request is initiated, which then displays it, right? If the URL corresponds to the servlets or JSP, then it is executed on the server, and then the result or response is returned to the client, which is then displayed by the browser. The last application is that the distributed applications. Java application can be divided into a number of modules or components which can run on two different machines at the same time. The Java programs or applications running on different machines can communicate with each other. So to be more precise, the Java object on one machine can invoke method on the Java object running on another machine. So that's the reason why Java will need support for distributed processing in the language by itself. The features of Java would be it's very simple and powerful. If the user already knows the basic concept of object-oriented programming, then the learning Java is a no-brainer because they share most of the language syntaxes, from object-oriented languages like say C++. And if you know C#, it is even easier. C# and Java is like sibling-like languages to each other. So Java provides the finite number of ways to achieve a given task, unlike programming languages where you are given with plethora of choices and that could leave you nowhere. The second thing is Java is secure. Right? Using a compatible web browser, you can safely download a Java applet without too much worry about the viral infection or malicious content. So Java achieves this production level, by confining a Java program in the Java execution environment by making it inaccessible to the other parts of the computer. Then Java is portable. Right? Our computers and operating systems are in use throughout the world and are many connected to the internet. So Java makes it extremely portable. So it is to give an assurance that any result on one computer with Java can be replicated on another. So the code is run in a different platform has the same result. Java is object-oriented. So Java support, all the features of object-oriented programming language, such as abstraction, inheritance, polymorphism, dynamic binding, message communication, etc. So with the help of these features, user can reduce the complexity of the program developed in Java. Java gave a clean, usable, realistic approach to objects. So we can say that the object model in Java is simple and it is very easy to extend, right? And then the robustness. Most Java programs in use today, fail one of below two reasons, right? One is the memory management mistakes, and the second is exception handling conditions. So with exception handling conditions, we have a try-catch block, so the programmer can easily handle the error in case of any exceptions that could come up. So they can prevent automatically by writing code accordingly inside the catch block. And the memory management, like say for C and C++, the programmer must manually allocate and free all the dynamic memory resources. So this sometimes could lead to problem because programmer will either forget to free the memory space that has been previously allocated, or sometimes they free some memory that another part of the code is still using. But Java virtually eliminates these problems by managing memory allocation and deallocation. So deallocation is fully automatic because Java provides garbage collection for unused objects, while the allocation with the help of a new keyword. So we have a keyword called the new that takes care of the memory allocation. Java is multi-threaded in nature. So Java supports parallel programming and multi-threading that allows multiple threads of different processes can run in parallel. It's called asynchronous operation, right? So the program is called a thread, And this type of programming is called multi-threaded, when each thread defines separate paths for its execution. So, multi-threading is a specialized form of multitasking. Java is architecture neutral. The Java designers, worked really hard in achieving their goal: write once and run anywhere model, right? As a result, Java Virtual Machine was developed because of this reason. So Java architecture neutral generates bytecode that resembles machine code and are not specific to any processor or any operating system. And then the next thing is that interpreted high performance, right? So I have not mentioned it here, but so the interpreted and high performance is that the source code is first compiled and generates the code into an intermediate representation called Java bytecode. That is highly optimized set of an instruction code that you can readily have. So this code can be interpreted on any system that has a JVM, that is Java Virtual Machine, is there, and it can generate the machine code. So Java bytecode was carefully designed by using the just-in-time compiler, what we call as JIT compiler, so that it can be easily translated into native machine code for a very high performance. Then it is distributed. Java allows the object can access information across the network with the help of something called remote method invocation, RMI. Means that this allowed object on two different computers to execute procedures remotely. So this feature support client or server programming. Then the dynamism, right? Java programs carry with them substantial amount of runtime type information that is used to verify and resolve accesses to object at runtime. There are like multiple uses of real-time uses of Java, but I'm just giving you only handful of it. Hope I'm not confusing anybody, but it is like a lot. But one thing is that Java is highly object-oriented, Java is customizable, and Java it is there, for you to help in any real-time programming need that you wish. And what is the fourth question? Method, function, and a class. Define each of them. Okay, let's go there. Method, function, and a class. Okay. All right. So the function is actually a piece of code that is called by name. Like say, for instance, even method is a piece of code that is called by name, but whereas method is associated to an object, function is disassociated. Like say, for instance, you have this class. Class is a container of those methods. So in Java, we only have methods. In C, for that matter, we only have functions, right? So when we have a class, a method will need to be associated to the class. Function can stay independent. Like say you are declaring an object. I've taken JavaScript as an example, where my object, and you're just declaring it, and then my object.go, it is a dynamic property you are creating, and then you're associating that to a function, alert hi. So now you are calling go, which is automatically bounded to my object, right? So in this example, go is a method to my object. So my obj object, sorry. Whereas in function, it is an independent function by itself, right? So you have a main function, you have inner function, you can call inner function, and then it says hi and all that, and you can call main function. So that is totally independent, right? So a method is implicitly passed the object on which it was called, right? A method is able to operate on the data that is contained within the class, right? But whereas a function is a piece of code, and it is called by name, and it can be passed to operate, and it can optionally return data, right? All data that is passed to a function is explicitly passed, and method, it is associated to an object by default. And a class is nothing but a container of such objects, right? So class, you can probably clone it to have multiple objects of the same class. That is exactly the difference. And I hope this example makes it very clear. Let me reiterate. My obj is actually an object, and you're creating go as a dynamic property. But here, go is actually a function. If you see the assignment, go is a function that is bounded to my obj object. It's actually an object. Whereas function is independent, it can be called from anywhere. In C, we have only functions, there is no method. In Java, we have methods. or I would say in Java, we only have methods. Let me quickly go to the next thing. I believe that is import. Okay. So import is actually a keyword that is used to import built-in and user-defined packages onto the Java source code, so that the classes can refer to a class that is in another package by directly specifying its name. Right? There are like multiple ways to import a package. So let me not go to number 1 and number 2. Number 1 is using fully qualified name, but it is not recommended. It's not a good practice. Defining fully qualified name, like say obj equal to new pack.a. No, I don't really need to specify fully qualified name here. Then to import only the class or classes that we want to use, like say this. Oh, I'm sorry, not this. Yeah, class that we want to use. Like say, for example, if we import package name dot class name, the only class within that class name with a package name will be available for use. So I can have say pack, so it's nothing but a package name. And I also say import pack.a. That means I'm importing only the A class of my package. So whatever the functionality that is available in class A is used in class B. And the third is to import all classes from a particular package. So in this case, you specify say, learn Java. So learn Java is a package. I'm saying dot star. Star means it's a wildcard character for all, everything. So I'm importing everything, all classes and subclasses underneath learn Java package, to be used inside the class second. So the keyword that is used to is import. So again, let me reiterate. So the import keyword is used to make classes and interface of another package accessible to the current package. So that is exactly what import keyword does. Some tips for healthy syntax in Java. Okay. You prefer returning empty collection instead of null. So I think that I would probably say that's like an important thing. Let me, for example, let me take this code as an instance, right? If you got to do it, like say, turn null, like say if you're specifying a city, let's say you are returning, it's a tertiary operator, you're checking if return null equal to city name, return blank, otherwise return city name. So in this case, you are actually returning an empty collection instead of null, basically. So it's an empty collection, provided if you really have a list or array list or array that is declared at the very beginning. That's the first thing. Second, avoid unnecessary object. Let's say, for instance, you have this, let's say, a public list, employees. Then you're saying if object is null, then you are instantiating your employee class. Then you are returning employees. Excuse the typo, just looking at it. So you're looking for a null check. You're doing a null check on line number 9. If it is null, then you're creating an array list. So you're making sure that you're instantiating the object only when needed. Then the third important thing is the memory leak, right? So there are like certain points to remember, right? Always release the database connection when your querying is complete. Then try to use finally block as often as possible. Then release instances stored in static tables. So they are the few steps to remember. And then other than that, you'll definitely get used to it as and when you start programming in Java. And then the testing thing. Okay, testing framework are used to create some unit testing in Java. Let's say for this, let's take this as an example. You are looking to concatenate two string 1 and 2, and it is going to return 1 plus 2. Remember, 1 and 2 are string variables, the string values, right? And you are decorating with @test, decorator. So when you @test is there, you're writing a method test concatenate. And then what you're doing is that you're instantiating my unit class, and then you're calling concatenate method 1 and 2. You're passing 1 and 2, and then you're making sure that 1, 2 is equal to the result. So your assert equal is going to compare the first value to the second value. If both of them are same, then it is going to return true. That is exactly why we have @test is there. So @test is actually a keyword. It comes with our Java unit test framework, and then you got to import a static class assert. Okay, so if the two values are equal, then nothing happens. Then the assert equal method is going to return normally. If the two values are not equal, then the exception will be thrown, and the test method would stop the execution here, right? And then the next part, what the instructors was asking is the exception, right? What are exception and how it is understood? Let's say, for instance, take this program as an example. We have d is 0 and n equal to 20, right? And then you are dividing n by d. So it's divided by 0 exception. Remember, your program is going to crash if it is not handled. There is no try catch, your program is going to crash, and the user will have no idea what had happened. But if you put a try and catch, so this is try, if you put a try and catch, then you at least printing a meaningful message to the user what had happened, and you are saving the program from caching. So it's not going to crash, and it is still going to provide a meaningful message to the user. And if you see, I have an arithmetic exception mentioned here, and then E is an instance, of arithmetic exception class. This exception is most appropriate to what had happened in the try. So for example, if you're doing some SQL operation, you can provide SQL exception. If you're providing mathematical operation, you provide arithmetic exception. Or like, let's say, invalid operator exception, null reference exception, overflow exception. There are many types of exception classes that are available. So you can, use the one that is more appropriate, or we can as well have a generic exception class, just exception. You can as well have simply an exception class like this to provide any generic exceptions. But the difference between such, specific classes and exception class is that when you get the value out of E, let's say, for example, you want to know the inner exception, you want to know the details of it. The more granular your exception class is, the more detailed your message you will get for that particular type. Generic exception can only give you a generic exception message, and that will leave you very little clue of what had gone wrong. Whereas a specific exception can throw much more of stack trace information and even more meaningful error message for that type. Okay, and IDEs. IDEs are called Integrated Development Environment. If you see an example, this is IntelliJ IDEA. It's an IDE developed by JetBrains. Previously, we were used to type Java code in Notepad, and we don't really know, because Java is case sensitive. For small s to capital S, small m to capital M for main, and system.out or something, we used to definitely miss out a lot. And for us to understand what had gone wrong, it would require a build and to deploy. Sometimes if it is a compilation error, we will know it by building it, but we don't know it beforehand because there is no predictive text alert saying that, you know what, you're typing it wrong. We believe you meant this. So there is no suggestion, there is no predictive guess that was possible in the traditional text-based IDE, in the traditional text-based editors. But now what we have come up with an IDE, Integrated Development Environment, where we get all development assistance, development aid, and associated toolkit to make our web development or application development a lot easier. And we have Eclipse, we have IntelliJ IDEA, and we have many such tools for Java. So those provide, number one, syntax checking, number one, on-demand compilation, number three, predictive text input, Number 4, better refactoring practices. And number 5, it can also tell you, whether what you are writing, there is also an on-demand debugger also. So it is going to do a runtime checking for you, and it is going to tell you if your input is this, then the value of this variable at this point is this. So it can give you that predictive guesses also, so that you can program accordingly to avoid any such possible errors also. Okay, so how can you go about debugging a Java program? So I'm using IntelliJ IDEA here. Let me not take this as an example. Okay, so I'm just going to see what's going to be my value at this time. I'm just going to want a debugger to be hit. See, it is hit on line number 5. On main method, it is hello world. Then I'm letting it pass. Then it continues and it prints hello world. So what is debugging is? Debugging is pausing the execution of the current program at any given point in time to assess the value of any particular variable and also to change the flow as needed. So if you have an if-else statement, you will be able to put a breakpoint. So this is called a breakpoint, right? You'll be able to put a breakpoint before or after or wherever you want, in the program, to even understand if the value is this, it is going to go to if. If the value is this, it is going to go to else. You'll be able to do the predictive analysis, and it is also helpful in understanding where the program could potentially take you to, right? So it wasn't possible in the text-based editor, but it was made possible in IDE world. Okay, I believe I have answered all the questions, more or like pretty much. So thank you so much for watching, and let me stop the recording here.